PN junction diode. PN junction is an interface of a boundary between two semiconductor materials, the P-type and the N-type, inside a semiconductor. In a semiconductor, the PN junction is created by the method of doping. The P side of the positive side of the semiconductor has an excess of holes, and the N side of the negative side has an excess of electrons. Now consider a thin p-type silicon semiconductor sheet. If we add a small amount of pentavalent impurity, a part of the p-type silicon will be converted into n-type silicon. It is called as the doping. There are two types available. One is a diffusion and a drift. There is a difference in the concentration of holes and electrons at the two sides of the junction. The holes from the P side diffuse to the N side, and the electrons from the N side diffuse to the P side. It gives rise to a diffusion current across the junction. There are two operating regions in the PN junction diode. One is P-type and another one is N-type. There are three biasing conditions for the PN junction diode, and the biased voltage is applied. Zero bias, no external voltage is applied to the diode. Forward bias, the positive terminal of the voltage potential is connected to the P-type, while the negative terminal is connected to the N-type. Reverse bias, the negative terminal of the voltage potential is connected to the P-type and the positive is connected to the N-type. Forward bias, the N-type semiconductor is connected to negative and the P-type semiconductor is connected to positive. When the P-type is connected to the battery positive terminal and the N-type is connected to the negative terminal, PN junction is said to be forward biased. When the PN junction is forward biased, the electrical field at the junction is applied electrical field in opposite direction. Both the electric field add up. The resultant electric field has magnitude lesser than the built-in electric magnetic field. Reverse biased. When the P-type is connected to the battery, negative terminal of the P-type N-type is connected to the positive side. The PN junction is reverse biased. The built-in electric field and the applied electric field are in the same direction of the built-in electrical field, creating a more resistive, thicker depletion region. The depletion region becomes more resistive and thicker if the applied voltage becomes larger. This is a characteristic curve for the PN junction diode. PN junction diode can be used as a photodiode. The diode is sensitive to the light when the configuration of the diode is reversed. It can be used as a solar cell. When the diode is forward biased, it is used in LED lighting application. It is used as a rectifier in many electrical circuits. Thank you.